Customer complains that we cut out the photocell when taking over outside lighting. So now I'm here doing some reverse engineering. The photocell was controlling the lighting outputs for those lighting contactors. So here's one of the lighting outputs. There's another one in there also. We're using a Pelican PM5 to trigger those lighting outputs. So we put the lighting on a schedule, but the customer complains that we cut out the photocell. Now, so I haven't worked on this panel, so I'm just looking for clues. So one clue that I find is a big relay labeled photocell. So that's where you start. And you start thinking, what controlled this relay? How were they using it before? Because when you walk up on it, stuff's all cut out, and so the whole relay is just loose and cut, and you've got to figure out what they were thinking and what they were doing. So the photocell, or the lighting contactors, take a 24 volt signal. We know that because we already put them on our PM5, which is passing through 24 volts. So we know that the contactors need 24 volts. So this relay at some point had 24 volts passing through the switching side, like normally open and common. So let's see. The purple from this relay is still going to terminal number 3. Terminal number 3 is jumped over to this brown, and the brown goes to the transformer. And so in order to determine whether that was 24 volts or common, I used my meter. And sure enough, 24 volts coming from the transformers. That's transformer power. So transformer power is put through to purple, and luckily they didn't cut that purple because it would have been hard for me to figure out. So 24 volts goes into common of the relay. So then, you just go and you look and you read the contact colors and the coil colors. It's a double pole, double throw relay, so it's got 2 sets of contacts in there. So one of the set of contacts uses purple as common, brown as normally open. So this brown would feed 24 volts to one of the lighting contactors. Now, they use a double pole because they were also probably doing the same thing with the orange and yellow. So the orange and yellow is the other set of normally open contacts, and they were probably fed into lighting wire number 2. All right, so then we had to determine, you've got either a 24 volt signal to trigger the relay or a 120 volt signal to trigger the relay. They're both cut, but one of them has a wire nut on it. So one of my technicians probably touched the black wire and not the blue wire. So then we start looking for a 120 volt source that used to trigger this relay. And the 120 volt comes into this box. It goes to this connection here, but that's a constant connection, so you wouldn't have this tied in because the relay would always be on. So another clue was that the common of the coil of the relay is tied into neutral, 120 volt neutral. So that just goes along with the idea that the coil of the relay was probably a 120 volt signal. So again, we're trying to figure out where the 120 volt signal came from to trigger this relay. So we know it's not going to be the constant 120, because then the relay would always be lit and the outside lighting would always stay on. So we're looking at these terminal blocks here, and that's where the constant 120 comes from. Then we find this red wire. This red wire was capped and kind of wrapped back. So we uncapped it and we said, let's check it with the meter. Well, we got 18 volts with the meter. When we checked between that and neutral, got 18 volts. 18 volts is kind of an indicator of not a good ground. So maybe it's trying to be 120, but it's not a good ground. And really, long story short, so we trace this up and it goes to this conduit. We trace the conduit up and over, and it goes straight out to the outside wall. Okay, so then I'm thinking, right on the other side of that wall, there's probably a photocell. And go outside, check it out. Sure enough, there's a photocell. So what's happening is, in this conduit we have 3 wires. We have constant hot, constant neutral, and a red wire. So I'm thinking the red wire has got to be switched. The red wire is going to be your load. So then we go outside, we find the photocell, and we cover it up with a jacket to simulate night. And after 1 minute of waiting for that photocell to react, sure enough, we get 120 volts on this red wire. So all we have to do is connect this red wire back to the coil of the relay, and we then can run our photocell relay in series with the calls from the PM5. So the PM5 runs the schedule, and as long as it is both dark and the schedule says run, the lights will be on. So when we walked outside, we found the photocell against the wall and eventually covered it up with the jacket to simulate night. So here it is. That's what a photocell looks like. And you can see inside of it. It's kind of nice, like an ice cube relay. You can see, it's clear, so you can see the guts. So that's the part of it that detects the light. And then it's kind of foggy, but inside there are some contacts, like relay contacts. Also, I found some, it's labeled. So it's got a model number. It's a Torque 2001 photo control or something. There's also a little note on the bottom that says, allow 1 minute for the thing to start working. So there is a 1 minute delay. So when I first covered it up with the jacket, I ran right inside and checked it with the meter, and it had done nothing. And I thought, uh-oh, maybe it's bad. But then upon further inspection, realized that I needed to wait a little longer. And after doing that, it worked. So here's what it looks like when it's all hooked back in. So again, the photocell has 3 wires running to it. The black and white provide 120 volt constant to power the photocell, and the red is the load. So the red is switched. So when the sun is out, the red is dead, and when the sun is down, the red is hot. So the red gets tied into black and white of the rib relay. Black and white is 120 volt signal to trigger the coil of the relay. All right, and then I used yellow and orange of the relay as the switching side. So yellow is common. It takes 24 volts from the PM5, which is scheduled. So the call from the PM5 is running on a schedule. So when the schedule says run my lights, it will go into the photocell relay, and if the sun is down, the photocell relay will return that 24 volts, pass it through to these 2 lighting contactor enables.